testing. Oh, hello? Why is the mic not picking up voice? This is weird. Um, hi. Good. Happy Friday. Yeah. um, uh, yeah. I guess I was like, I'm gonna tell why I wanted to make coffee, and it's Arabic or coffee, but it's not. Um, yeah. Wait, did I do something with the mic? It's not picking up. Talking, shouting. Can I just did filter? It's a limiter. Uh, okay. At default, I talk. I don't know. Anyway, yeah. So I wanted to make coffee, like I said, and I tried making it. I waited like 10 minutes. It's a type of thing. I think last time I checked, it's called a which I don't just coffee. I don't know. And and it just wasn't boiling because it's too fine compared to I don't know. So like it just wasn't preparing. So I was like, okay, like good. So while making that, the coffee ready almost. Um, so so now I made a hybrid of Frankenstein's monster of a hot cocoa Turkish slash Arabic. It actually tastes really nice, but it's a monster. And that took me half an hour. Uh, yeah. Okay. So it's been such a long time since I think it's been what happened. I swear I'm talking and I don't see the thing moving. I said, let's see if I remember what I've done, but it didn't pick it up. Don't feel like yelling. I'm holding the mic so close to my mouth. It is annoying. I'm gonna try. Ah, ya Allah. I'm just gonna reset everything. It's going to be so much fun. Nothing changed in the gate, I'm guessing. Is this a good thing or a bad thing? Hello. Okay. I think it's better now. I updated the open threshold. I'm gonna update it a bit more. Okay, I can talk like a human now. Whoa. Is it working? Yes, it's working. But why does it look like my voice is low? Hmm. Anyway, so yeah. Um I think the last update was me trying to run this one more time, even though I didn't do the what is it called? When snapshot? When you take snapshots? I didn't do that. The um the I tried running it and uh something would max out. It wasn't even like I was even normally running it and it just wasn't working. So I think I said that last week as well. Yeah. So I can happily say that I failed here. Um, and that means I won't be able to continue uh, running it. Um, but yeah, I guess I'm just gonna be reading it, which is not fun, but yeah. All right. Um, how do I make the phone not go to sleep? I don't know. I should have. Yeah. Anyway. Uh, okay. Ignoring your chat. Um, okay. Where was I? I know I was here, but was I here? Hmm. Let me check. This. No, we're past that. Okay. So we're past the here. Okay, here. Code generation with a pipeline. Okay. Um, by the way, for me, the stream is really good right now. Um, and and um, no dropped frames. Everything is green. Twitch is green. Let me see if YouTube is happy with me. YouTube is happy with me. Everything is good. Um, yeah. Okay. How fun was the last stream that we did with Z? She's amazing. So smart. I'm like, how can you know physics and computer science? That's too much. Mm, I guess having something as a hobby is cool. Because I really like astrophysics, but I don't like it to the level of like trying to understand it mathematically. Like I'm happy surface level, watching like um mm, yeah, like YouTube videos about it or document. Stream is good. Mike is quiet, right? I agree with you. I quiet the coffee story. Mm, okay. Um, mm, okay. There's a delay. Okay, I'll try to hold the mic closer to my mouth. That's all right. Um, I really would like to buy a microphone clamp thing someday, but I haven't seen it. Mm, I think actually they are available online, so I can order one. But um, yeah, yeah, because like right now I'm using phone holder that I wasn't using a few weeks ago, even though like I had it. But I'm really happy with it. Otherwise, like I don't know if you remember, but sometimes my phone would fall over. It's not gonna do that because I'm using a really nice phone holder. Um, so yeah, it's nice to have a good setup. It makes the feeling of like, oh, I'm gonna do this to, hey, I'm gonna do this because everything is ready. Um, yeah. Okay, so I'm gonna read through this. Okay. Mm, and see, like, I'm just gonna read through this, which is probably going to be boring. So, yeah. So, last time we did normal, uh, arguments and training. This time we're using code generation with a pipeline. Are we using acceleration? Ah, okay. Mm, I don't think so. Oh, sorry. This is inference. This is inference for the thing that should have worked. Hey, I can actually steal their code and just inference their stuff. I could do that. But um DS, what language were they using? Was I using the same language as, I don't think I was using the same language as they were. Let me double check. Maybe I was. Maybe I didn't change anything. Mm, language, parrot, DS. What was DS? Uh, I guess I didn't change anything. Cool. So I'm just gonna steal their inference. I'll need to run some of the stuff at the top. I guess I don't need you. Shouldn't need you. I need you. It's not really. Um, um, mm, mm. How much do I need to run for it to work? Nothing, right? Because it's just inference, unless it's some imports. Um, so like you. Oh my God, I just remembered what we were doing. It's the code generation thing. Okay. Wow. I really did forget. Um, all right. We can update this. Um, create some data. Will it do that? Create a scatter plot? Oh my God. I don't know if I've said this, but I started a course and I'm learning basic Python. And it's really useful, even though I've been using Python for how long now? Um, at least 5 years, but not like consistently. I realize how much I appreciate foundational knowledge. Um, so yeah, like literally, I was creating a scatter plot yesterday. So let's see if this does better. Oh, it will. Ah, okay, it's just X and Y. Okay. I'm gonna say create a scatter plot. Um, uh, where the line is like pink. Let's see if it knows to do that or not. Because if it does, I'm gonna lose it. Um. Oh. 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 It didn't have enough. What do you call it? Uh. Not enough lines. But look, it's trying to use. Why are you trying to use? Oh God. Why isn't there enough lines? We're not limiting anything, are we? Oh. Hmm. Let me make it two. I don't know what that means. Nope. Okay, fine. Shut it. Um. I'm just gonna say a pink scatter plot. Create a pink. Is there red is a smaller. Okay, that's smaller. Oh, trying to write more comments for me. Okay, fine. I failed. I mean, it failed. One more time. All right, sure, might work. First one was actually better. If I go back to one, does it change anything? Oh wow, it did. What the hell is number of return sequences? And color black. You actually colored it for me. Now I'm happy. Um, because I think that the code that it returned didn't have color. See, it didn't. I think I planted it in its mind that I wanted color. Wow. All right. What else? Looks pretty fine to me. Um, does it with pandas operations with data frames? All right. Um, create data frame from X and Y. Um, with Z, where Z is X plus Y. Ha ha ha. I'm asking too much. Let's try. No, Z equals X minus Y. This is funny. Um, okay. Go back, go back. It's fine. Huh? What the hell is that? All right. What does that mean? Hmm. Okay, yours is pretty different, but good. Inserting. Why though? Do you need this when this is already here? Nice, that's the correct answer. Although yeah, exactly, inserts X again. Um, since the number of generated tokens is limited for the following for loop is cut off. Let's see if we can do something a bit more complex and have the model help us use the group by operation. Mm, yeah, I've been trying to write code myself, and then when I get stuck, mm, did I use ChatGPT? I don't think I did yesterday. because there was an exercise that I had to do. Mm, but like I use it for my normal code usage, not for exercises where it's for the sake of my learning, you know? Even though I don't mind doing it. Anyway, um, where was I? Next is the group by operation. Um, data frame. Here's our data frame. Profession and income. Where's it coming from? The mean income per profession. So this is the code that it got last time. Let's see what we get. Nothing. We got nothing. Defining. It's trying to define something. Okay, it does change it. Yeah, you're failing. Nope, that's not it. All right. It's trying. It's trying. But yeah, it worked for them. Not bad at all. That's the right way to do it. Let's see if it can use scikit-learn. Set up a random forest model. What the hell is that? I mean, um, yeah. Wow. I mean, I know it's a random forest, but I'm just saying, how do you set it up? Apparently like this, using scikit. Ah, okay. So it's calling it. It's starting something, and then, oh, so that's the code that it came out when we run it. After, yeah, no, it's trying to write more comments, and now it's saying, trying to define something. Hey, oh wow, it actually worked this time. That's so cool. Yeah, yeah, that's cool. Okay, now what? What's this next one? Test, test. I see test, test. That was pretty cool. Looking at these few examples, it seems that the model has learned some of the syntax of Python data science stack. Of course, we would need to evaluate it more thoroughly before deploying the model in the real world. Yep, yep, got it. Sometimes it requires more customization of the model training to achieve the necessary performance for a given use case. However, for example, if we would like to dynamically update the batch size or have a conditional training loop, okay, that skips bad examples on the fly. One option would be to subclass the trainer and add the necessary changes, but sometimes it's simpler to write the training loop from scratch. That's where accelerate comes in. Okay, so this is using accelerate. Okay, all right. Okay, training with accelerate. We've seen how to train a model with the trainer, which can allow for some customization. However, sometimes if you want full control over the training loop, or we want to make some exotic changes, in this case, HuggingFace Accelerate is a great choice, and in this section we'll go through the steps to use it to train our model. To make some things more interesting, to make things more interesting, we'll also add a twist to the training loop. This looks like YouTube video where it says, "Wait till the end, something interesting will happen." Why are you trying to retain my attention? It's not like you're getting paid by the minute. All right, custom loss function. All right. Hi, Chet. Hey. What's up? How are you doing? Um, Chet is a really cool streamer that as far as I know, does lead code solving stuff. How did I decide to take this course? Good question. Um, do you know that what this course? Oh, okay. Wait. Okay. HuggingFace, help me. Don't embarrass me. So, oh. Mm, okay. I'm glad that you're good. So HuggingFace, the platform, um, it's it's not a learning platform actually, but it does have courses. It has an NLP course and a few others like audio course, which actually my plan is to do this next. Inshallah, we'll see. Um, it has a bunch of ML related courses, and this is not the oh my god, my yeah, this is not the only course that I'm taking. It's like I'm taking two courses at the same time, and this is one. Um, I'm interested in machine learning with language, which is natural language processing. I'm sure you know, but yeah. So the reason I decided on the Hugging Face one because I was like, oh my god, Hugging Face has a course. um, like if you think about ML courses or NLP courses, what comes to your mind? Most likely the Coursera one with Andrew Nick. But that one, to be honest, is too complicated for me. I wanted something that was focusing on creating things practically. So I would like to think that that's it. But also, if I want more um, lecture style, like theory style stuff, um, there's this advanced NLP course from Carnegie Mellon University taught by Neubig um, that we watch on stream. So I couldn't decide between one because they're quite different. Yeah, is that an answer? I don't know if it is, but I tried. I tried. How's learning going on your side, kiddo? I hope learning is going well, and don't stress about it too much. Okay. Inshallah, good things will happen. So I'm gonna play this video. Why are you not zooming in? Zoom in. Oh God, what's happening? What's happening? Oh, okay. Sorry. There we go. Oh my God. Why are you? Oh my God. This is how I have a friend who, when we say cool, we write cool like that to each other. Wow. I that give me flashbacks. Um, that's great. I'm glad that you're improving. Um, yeah. Lead code is really like gamified, so it's easier. I would like to hope to like want to continue. Um, yeah. I guess even for us, like streaming is part of the gamification, right? For the learning. Oh, is it too loud, by the way? Because my voice is way too low, annoyingly. Okay.
In this video, we take a look at setting up a custom loss function for training. In the default loss function, all samples, such as these code snippets, are treated the same, irrespective of their content. But there are scenarios where it could make sense to weight the samples differently. If, for example, one sample contains a lot of tokens that are of interest to us, or if a sample has a favorable diversity of tokens. We can also implement other heuristics with pattern matching or other rules. For each sample, we get a loss value during training, and we can combine that loss with a weight. Then we can create a weighted sum or average over all samples to get the final loss for the batch. Let's have a look at a specific example. We want to set up a language model that helps us autocomplete common data science code. For that task, we could We would like to weight samples stronger where tokens related to
Yeah, is this? Oh, okay. Yeah, no, you're right. It's still not good. Trying not too loud, but it could be turned down a bit. Okay, I'll do that. Okay. I'm trying to make it relative. Yeah. Let's try again.
the data science stack, such as PD or NP, occur more frequently. Here you see a loss function that does exactly that for causal language modeling. It takes the model's input and predicted logits as well as the key tokens as input. First, the inputs and logits are aligned.
I think it's pretty reasonable now, right?
Then the loss per sample is calculated, followed by the weights. Finally, the loss and the weights are combined and returned. This is a pretty big function, so let's take a closer look at the loss and the weight blocks.
Merci, thank you.
During the calculation of the standard loss, the logits and labels are flattened over the batch. With the view, we unflatten the tensor to get the matrix with a row for each sample in the batch and a column for each position in the sequence of the sample. We don't need the loss per position, so we average the loss over all positions for each sample. For the weights, we use Boolean logic to get a tensor with ones where a keyword occurred and zeros where not. This tensor has an additional...
So Coffee is chatting in Twitch, and Chat is on YouTube. And I don't know if you guys can see the chat, but Coffee's trying to say hi to Chat.
dimension as the loss tensor we just saw because we get the information for each keyword in a separate matrix. We only want to know how many times keywords occurred per sample, so we can sum over all keywords and all positions per sample. Now we're almost there. We only need to combine the loss and with the weight per sample. We do this with element-wise multiplication and then average over all samples in the batch. In the end,
I really need to go back and understand what is being said, because is he going over each line of code? Okay. So we get input logits. So we have label and logits. Okay. And then calculate per token loss. We get loss. Was what he explaining different?
this is a pretty big function, so let's take a closer look at the loss and the weight blocks. During the calculation of the standard loss, the logits and labels are flattened over the batch. With the view, we unflatten the tensor to get the matrix with a row for each sample in the batch and a column for each position in the sequence of the sample. We don't need the loss per position, so we average the loss over all positions for each sample. For the weights, we use Boolean logic to get a tensor with ones where a keyword occurred and zeros where not. This tensor has an additional dimension as the loss tensor we just saw because we get the information for each keyword in a separate matrix. We only want to know how many times keywords occurred per sample, so we can sum over all keywords and all positions per sample. Now we're almost there. We only need to combine the loss and with the weight per sample. We do this with element-wise multiplication and then average over all samples in the batch. In the end, we have exactly one loss value for the whole batch. And this is the whole necessary logic to create a custom weighted loss.
Oh.
Let's see how we can make use of that custom loss with Accelerate and the trainer. In Accelerate, we just pass the input IDs to the model to get the logits, and then we can call the custom loss function. After that, we continue with the normal training loop by, for example, calling backward. For the trainer, we can override the compute loss function of the standard trainer. We just need to make sure that we return the loss and the model outputs in the same format. With that, you can integrate your own awesome loss function with both the trainer and Accelerate.
I mean, I don't have an awesome loss function, but I saw that I was trying to override the trainer's compute. Where is it? Compute loss. Where is it? Do we not do it? Oh well. Okay. So like I said, I don't know if I'll be able to run the code due to resource limitation, but if I can, that'll be pretty cool. I can try, but yeah, most likely just stealing what they did their model, because I think from what I remember, motorcycle is passing. I don't know if you can hear it. Um, I think even the accelerate is taking on the previously fine-tuned model. This one step of backpropagation per mini batch, that's different to the usual handling of mini batches, isn't it? I have no idea. So we're gonna go through what he was talking about because that's how it is. You get the video and then you get the explanation again. So let's see if that's the case because you should not expect me to remember anything. Okay. So, since we are mainly interested in sensible auto-completion, wait, we don't want senseless code. Okay. For the data science libraries, it makes sense to give more weight to training samples that make more use of the libraries. We can easily identify these examples through use of keywords. Okay, so the keywords he's talking about is the things that we identify, meaning the libraries, such as PLT, pandas, scikit. Oh, wait. Oh, so these are keywords functions and predict, which are most frequent imports from matplotlib and pandas and scikit-learn, as well as fit and predict being pattern of the latter. If these are each represented as a single token, we can easily check if they occur in the input sequence. Tokens can have a white space prefix. Yeah, because it's indented, right? So we can, yeah, each time my phone gets dark, yeah, it's fun. So we'll also check for these versions in the tokenizer vocabulary. To verify that it works, we'll add one test token, which should be split into multiple tokens. Okay, we give a um look at that. These are starting tokens, and these are no, no. Actually, we have them twice with a space and without a space. Okay, and then we say here you go. Keyword has not single token test. Correct? That is, we're checking input ID 0. Can we check? Oh, oh, where is the tokenizer? Take me there so I can run the code. Take me. You can't take me. Take me. Up, up, up. Tokenizer. Tokenizer. Is that it? Tokenizer. Well, uh-oh. Ah, here it is. Hmm. Do we need the data set? We probably do. See, I needed to run some stuff, but I didn't, and now I am reaping what I sow. Mm, okay, fine. This is not smart, but I'm gonna run everything up. Let's do a restart. Sure, why not? run before, and then run this here, and that's about it. What happened? What happened? You didn't run before, did you? Oh, whoa. I don't get it. Still trying to connect. Okay, do that. Connecting. Yeah, but I thought it would like wait for me. That's weird. Why is it still connecting? It's not like I don't have internet. Refresh? Does it add anything? Thanks. What? To execution? What is executing? Huh. Alright. So something is executing. Okay. So seems to work nicely. Change. Oh. Okay, we can do that. Maybe it ran out? Possible. Still trying to connect. Oh, okay. And then we say run before. And then we don't train to make sure that we don't train. And then you run this one. And then you can come here. And we'll wait for that to finish. Could take a couple of minutes. Okay, seems to work. We can now write a custom loss function that takes the input sequence, the logits, and the key tokens we just selected as inputs, which are these little things. If we need to align the logits and inputs, why can't I read? First, we need to align the logits and inputs. The input sequence shifted by one to the right forms the labels, since the next token is the label for the current token. We can achieve this by starting the label from the second token of the input sequence. Okay, so we have label and then token. Since the model does not make a prediction for the first token anyway, first token being start of sentence, right? Then we cut off the last logit. We don't have a label for the token that follows the full input sequence. That's also the end of sentence, right? With that, we can compute the loss per sample and count the occurrences of all keywords in each sample. Finally, we calculate the weighted average over all samples using the occurrences as weights. Okay. Calculate average over all. Since we don't want to throw away all samples that have no keywords, we add one. Oh, really? Okay. So what
As a
is
favorable diversity.
wait? Okay. What is being talked about is this thing we saw. We have keywords. We say 1. If we don't, it's 0, and then at the end we add a +1. So the ones that okay. Yeah, so the 0 becomes 1 and everything else gets a +1. So if it's a keyword, if it has a keyword, it is higher. So key token weighted loss, if there are keywords, it's a good thing. This is us getting input and logits. Yes. where are we giving the keys? Calculate per token loss, resize an average loss per sample, calculate scale and scale weighting, and then this is weights. Is that the +1 we said we would add? Before we can start training, this is still loading, by the way. Running, maybe? Okay, getting data set. I think that takes like around 10 minutes. Before we start training this awesome new loss function, we need to prepare a few things. We need data loaders to load data in batches. We need to set up weight decay parameters. From time to time, we need to evaluate. So it makes sense to wrap the evaluation code in a function. Okay, let's start with a data loader. We only need to set dataset format to torch, and then we can pass it to a Python data loader with the appropriate batch size. We have batch size of 32. Okay, tokenize to torch, data loader. Okay, shuffle, and then eval. Next, we group the parameters so that the optimizer knows which ones will get an additional weight decay. What does that mean? Usually all bias and layer norm weights terms are exempt from this. Okay, no decay, bias and layer norm weight. Okay. I don't understand this. Please explain it. Yeah. Group parameters. Parameter knows which ones get additional weight decay. So these are the no decay ones. So we loop through them and say append P. What the hell is P? Named parameters. I don't get this one. Since we want to evaluate the model regularly on validation set during training, let's write a function for that as well. It just runs through the evaluation data loader and gathers the loss across the process. So eval data loader, give me outputs, get loss, get lost. And then you mean it. If you don't mean it, it's all right. And then perplexity. And then it could be infinity. Cool. And then you return loss and perplexity. With the evaluate function, that's the evaluate function, we can report loss and perplexity at regular intervals. Next, we redefine our models to make sure we train from scratch again. Okay, so I thought we were training on what we have, but apparently we train from scratch, which I do not expect me to do that. We can then define our optimizer. It's just Atom W, yeah. Using the function from before to split the parameters for weight decay. Get grouped params. All right. Let's prepare the model optimizer data loader so we can start training. We call accelerate. We give it model optimizer data loader for training and eval. If you're training on a TPU, you'll need to move all the code starting at cell above to a dedicated training function. I'm not. Okay. Now that we have our train data loader to, okay, so yeah, accelerate.prepare. we can use its length to compute the number of steps. Remember that we should always do this after preparing the data loader. This method will change its length. We will use a linear schedule, classic linear schedule for from learning rate to 0. Okay, linear. Wait, we don't set learning rate? Epoch 1, length, here you go. Steps, here you go. Optimizer, warm-up steps. All right, you're still getting the data? No, you already got the data. What are we doing right now? We are tokenizing. Okay. Lastly, to push our model to the hub. Okay, you name a repo, you push it. Got it. You can add it to a local folder if you feel like it. And then before we train, we check for if the evaluation is working. What are these numbers? That's a 10. Those are very high values for loss and perplexity, but that's not surprising as we haven't trained the model yet. With that, we have everything prepared to write the core part of the training script. For the training loop, in the training loop, we iterate over the data loader, pass the batches to the model. With the logits, we can then evaluate our custom loss function. We scale the loss by the number of gradient accumulation steps so as not to create larger loss when aggregating more steps. Before we optimize, we can also clip the gradients for better conversions. Finally, every few steps, we evaluate the model on the evaluation set with the new evaluate function. God, my brain hurts. Oof. Okay. So we have gradient accumulation step, which is 8. Okay. We have eval step of 5,000. We say model.train, and then completed steps is 0 for now. We loop over number of epochs, which is 1 actually. So yeah. And then we say for each batch, this TQDM taqaddum is the thing that tells you where you are, so it has to go over steps. Yep. Enumerate, start from 1 to the number of yeah, okay. We get the logits. This is our loss because we're calling the thing that we made. If the steps isn't 100%, because it says, yeah, that's what it means, right? Even though it's modular. Accelerate, print, sample, step, train, loss. And then loss is loss divided by gradient accumulation steps. We step backwards. If this thing optimize, what is that? Accelerator, optimize learning schedule, optimize 0 gradient step, and then 0 gradient, and then plus plus for the completed step. And you're still getting tokenized. Okay. We get loss and perplexity, and then we print it, and then you say, why though? Model.train. Wait for everyone. All right. Unwrap so that, yeah. Wait, this is at the end, right? So that you save it and then you send it. Push to hub. god, this is brain hurting. And that's it. Okay. You now have your own custom training loop for causal language model such as GPT-2 that you can further customize to your needs. Thank you. I mean, we can always come back to this, but yeah. What am I supposed to do? Create my own custom? No, I'm not gonna make a custom loss function. Oh my god, that would be cool. To look at like a tensor board or what weights and biases. That would be pretty cool, actually. Like I would ever. No, but thank you for thinking that I could. My god, I'm tired. All right. So technically, we can press next, but we're not gonna start this. Yeah, it will be cool though. Like when we get to it. I'm gonna wait for this to run. In the meantime, we will start our lecture. I'm gonna say that even though I have been lacking in the learning with these lectures, I did it's up to 7 lectures for the full part. I was watching lecture number 2 yesterday, and it was talking about loss function. So I'm like, I like watched it for a very brief time. I didn't have much time to do it, but like I'm glad that it was talking about loss function and that I was reading about loss function today. Even though today's yeah. Oh wow! Look, eval metric something something. Is that batch? What does the BT stand for? Yeah, 88%. Okay, I'm gonna have to refresh this because if I don't, it won't work.
So the second
Okay, I'm probably gonna need to. How's the voice? I don't know. Let's see.
the next thing I want to talk about, this is something that people think about a little bit less, but it's actually something really important to know because it will affect you, it will affect everybody to some extent. It will affect you to a greater or lesser extent, depending on what type of, you know, system you're building, but it will definitely affect everybody. And that's the mismatch between the function that you're optimizing at training time and the evaluation metric that you're evaluating. And so, like,
Wow, I didn't realize we were this aligned. That's pretty cool.
as I said in the reinforcement learning class, it's very common to optimize for maximum likelihood for training. But there's all kinds of problems with this, with respect to the mistake, it not being sensitive to mistakes, it not being sensitive to your generation algorithm. But even though your likelihood is getting better, accuracy can get worse. And this is a super simple example with image classification on MNIST. And I ran this experiment with like 10 lines of PyTorch code or something like this, maybe more, like 40 lines of PyTorch code. And so here on the left side, we have the loss on the training set and the test set or the dev set. And here we have accuracy on the training set and the test set. And so, whoops, I showed you the answer.
I didn't see
I was going to do
it.
a quiz, but I accidentally showed you the answer. But the problem here is basically because the loss, you're calculating the likelihood of the correct answer. And the likelihood of the correct answer is the probability of getting the correct answer. The accuracy is the number of times you're getting the correct answer. So as you train a model to get more and more confident, it gets better and better at getting more answers correct, but it also gets more and more confident in its answers. And so if there's any example that it's really bad at, it might get very confident in that answer, that bad answer, and the log likelihood of that answer will go up. Or sorry.
So it will get more confident in bad answers as well.
the log likelihood will go down, so the negative log likelihood will go up, is the loss. So basically, the loss that you're calculating and the thing that you care about in the end, accuracy, can be decorrelated. So there's also an interesting example in text generation, and this is part of the reason why we have all these other text generation algorithms like nucleus sampling or top K sampling or other things like this, is actually in a maximum likelihood trained model, better search, in other words, finding a better model score doesn't necessarily give you a better generation result. And
Why?
this is an example from machine translation from a really long time ago, but it still persists today, which is they did beam search with a larger and larger beam, and the best beam for finding the best scoring output basically was 4, and then the accuracy goes down and down and down as they find a better output.
Finding a better output. Huh. Oh, so the more you search does not mean the better you find the correct thing? By the way, this stopped running, meaning it's halfway done. What I could do is I ran this, we run this, which is a definition. Eh, but I just ran it. I swear we made the tokenized dataset, did we not? It took me a bajillion years. Isn't that it? There you go. It's ready. Look. Yeah. Did I delete it somehow? How can you not see it? Does this make sense? Yeah. How's that possible? It says data sets with an S. Do we have data set without an S? I don't know. Let's search for it. Data sets. There's an S. There's always an S. So I can just yeah, no, there's an S. Does it matter? Yay, it worked. And then that, and then you, and then we get the model again. Atom, accelerator, GG. Why? Uh-oh. Really? Really? And if I don't give you that? Whoops. And so this evaluate, most of the time, I think we had something. I thought we had something. Does not exist? Let me see what exists, because I remember creating something. There was a repo, for sure. There it is. Name, that's fine. I'm just gonna not name it accelerate. That's cool. Even though it's coming from accelerate. Try again. It does exist. Okay. This evaluate takes usually a lot of time for the bug fix. Was it a bug fix or was it changing code that I shouldn't have? I don't know. Thank you. Thank you. This evaluate takes a lot of time, so I'm gonna let it run and not expect it to work. Yeah, cool. Going back here. So more search does not mean better result. I mean, obviously though, right? the more you search for problems, the more you find it. It's not like even if you don't search for problems, you will find more problems there than solutions. That's life.
And does anyone remember when we talked about the generation class where this comes from?
No,
I don't know how explicitly we mentioned it in the generation class,
I
but
wasn't there.
basically the problem is
Wait, by generation class, he means one of the lectures where he was talking about generation? Oh, there it is. I was there. Okay, cool.
maximum likelihood trained models like shorter outputs generally, because if as we make the output longer, the probability of the longer outputs goes down. So
I remember us talking about the blue score and how it works. Like for example, I remember like finding problems with the blue score at least. I don't remember well, but I remember something. Yeah, evaluate it's taking its time. Okay.
So as you improve the beam, it will start generating shorter and shorter outputs. And because of that, the score goes down because blue score doesn't like outputs that are too short, essentially. So there are hacks around.
Was it that? Like if the input is long, output is short, you get a bad blue score or something like that? I might be wrong. Is it like keyword based or something? I think so. It like compares like I remember one where it was yeah, like if your output is long but it's wrong, you get a better score. Um it it counts and does an average? Maybe.
Around this for beam search, where essentially what you do is you take the average log likelihood of each token instead of the overall log likelihood of each token. And that improves a little bit, but still you can see as you search more, the accuracy goes down. So,
Ah.
so that's the general idea here. There's a bunch of ways you can fix this. The most principled way is to use a method like reinforcement learning or something, some sort of structured training algorithm that allows you to train your models so that you don't get these bad outputs. Another way that's much easier is to do early stopping with the evaluation metric as opposed to early stopping with the loss. And by doing this, you would stop here. So you would stop where you get the highest evaluation metric that you care about, instead of stopping here. So
Question, how do you know? What if we get another high somewhere if we continue? You know?
that's one way you can fix this problem. Does anyone have an idea about why this might be a bad idea?
Yes.
Why might it be a bad idea to stop here instead of stopping here, for example?
As a greedy person, there's always something better. The grass is always greener on the other side.
Yeah.
So
It's kind of overfitting. It's overfitting in a particular way. But remember here, this is still the accuracy on the dev set. So we're not overfitting so much that the dev accuracy is going down. That would be a different variety of overfitting. But any ideas? Go for it.
We don't want it to be too confident in the wrong answers.
Yeah, exactly. We don't want it to be too confident in its wrong answers. And we talked about calibration, where calibration is basically like how accurate are the probability estimates. So this model over here is going to be really poorly calibrated. It's going to be very confident regardless of whether it's correct or not, and that could be a problem in downstream tasks.
Okay.
There's also another thing that I forgot to put on.
What other thing?
That I forgot to put on the slides, but it's an interesting phenomenon that actually kind of a lot of people in interpretability are interested in. It's this generalization, grokking generalization beyond overfitting on small algorithmic data sets. And basically what they show
Why have I heard that? Have we discussed this before?
Is you can be training for a very, very long time, and like reducing the loss, reducing the loss, reducing the loss, and reducing the loss. And it's only after a very long time does your model start generalizing well and getting good accuracy. This paper, the types of data sets it's talking about are data sets where you need to get many things in a row correct before you get the final answer correct. So basically you need to get like,
Okay, I don't know. Yeah, you're probably right because I remember hearing the word grokking. It's not something you talk about every day. Thank you, thank you.
20 steps in a row or 50 steps in a row correct before you get the final answer correct. And basically, the reason why this happens is because this accuracy will keep going up, but you only get the accuracy of each individual decision will keep going up, but you only get marked like correct after you get like all 50 in a row correct. So this difference can be even more stark when you're talking about things that require like 50 steps of reasoning or like multiple steps of reasoning, but like 50 token generations correct before you get them right. So that's another thing to be aware of.
Okay, okay.
Cool. So now I want to switch gears a little bit to actionable evaluation and how you can evaluate your models in a way that makes it easy to find next steps to be improving. Are there
There are several models that have been called grok. Ah, uh-oh, there aren't grok models. Like oh my god, you're right. The X chatbot, the Twitter X chatbot. Oh, I started Blue Sky yesterday. I created an account on Blue Sky, and it feels so nice. Like there's a tab for people you follow, and then there's a tab for like discovery something. I like that because like on Twitter you get people in your feed that you don't follow, and that's very annoying. So you can just see the people that you follow, which is really nice. And I'm guessing it is like chronological, like normal. So yeah, Blue Sky, cool. In general, computer nerd uses to grok say documentation means to understand it well. Huh, really? So the word grok has an actual meaning? I thought it was like when you Google it, it says it's the X thing. No. Yeah, to understand. Oh wow. That's cool. That's cool. That was Wikipedia. Um all right. So for some reason I want to pause here. Because if I continue, oh wow, look at your data. Look at what you did. Because yeah, see, yeah, it continues for a long while, which is like another at least 10 minutes. Um, that's cool. Wait, is that a different guy? Is a different guy going to talk? Cool. I mean, I do have time for another 10 minutes. I was like going to go on here, but sure, we can continue. It's all right. I will continue. See, evaluation is taking too much, and it's just a test. It's not even real. Anyway,
any questions about the debugging part before we get into this part? Okay, if not, I'll go ahead. So my first suggestion with respect to how you can...
oh, hi Mark. Thank you. That's so sweet. Have to let my daughter know about your channel. Oh my god, that is so sweet. I'm gonna cry now. Oh my god. Thank you. Good night as well. I, I was thinking about like making some beginner related videos because what I'm doing is not really beginner, but I feel like it's already so saturated. Oh my god, thank you for this. Thank you for subscribing. I really, really appreciate that. Thank you. And please, if anyone has any questions, I will happily try to answer. So if it's not today, if it's another day, I will happily do that. Thank you. You really made my day. That's really nice. Wow. Good night. Rest well. Thank you.
Actually, improve systems is make sure that you're looking at the data that you're using. And both bugs and new research directions can be found by looking at your model outputs. So to give one example of a very common mistake that you can make when you're creating a generation algorithm, it's these sort of off by one errors. So like, let's say you implemented a translation system and it's generating outputs like went to the store yesterday, bought a dog. You can immediately look at this and
Thank you. Appreciate it. Yeah. If like anyone wants to learn anything, I will happily, if needed, make a video short, something about it. But then I'll have to know it. We'll see. Rest well again. Thank you. Good night.
say, hey, this doesn't look like natural English. What's going on? And the problem here is you're doing something like output one, and you have a slice of like 1 instead of 0 here or something like this. And so this is a really silly error that you might just make a mistake on Python.
Oh, wait. So it says look at your data, but does that mean generated data or what you give to the model? Because what you give to the model really matters. So went to the store, bought a dog. It's technically not a lie. You can go to the aren't there pet stores where you have to pay to buy like fancy dogs? I don't think that's an error. Like went to the store, bought a spaceship. Okay, that could also be possible because it's a space toy. Trying to bought a human. Okay, that's wrong.
Python on your pre-processing or post-processing or something like this. But the problem is, like, if you look at your blue score based evaluation or something like that, you'll be 1 point.
He's suggesting the error in this case is dropping the first word, I think. Oh. Oh, okay, so bought a dog. There is no subject? Yeah, the thing that does the thing. Okay, I mean, for me, it would be like, I bought a dog, so I don't need to. Okay, fair. Okay, I see what you mean.
Point worse or 2 points worse or something like that. And you'll be like, oh, I'm 2 points worse. Why am I 2 points worse than the state of the art? And it turns out it was a really like silly thing like this. And immediately you'll see this if you look at your data, but if you're doing all your experiments and just looking at the numbers, it's really hard to tell, why this is happening.
So, okay, you don't need to just look at the numbers. You can look at what output it's giving you. Is that his note?
Another thing is if you have a good eye.
Comma instead of a dot, rocket exploded. Okay. I don't think I understand what you mean for that one.
And can like just look through the data points. We as humans are pretty good pattern recognizers, and especially CMU students, you're very good and quick at picking up on things. So if you look at the data and pour through things, you can probably pick up patterns about why things are failing. And so you might look and see that compared to some other model, your model is really bad at answering questions about people or something like that. And then you figure out you'll need a better model of people, or your RAG system that you're building for assignment 2 is maybe failing on all the research related questions. So you need to come up with the research.
Hold up. Our assignment 2 is a RAG thing? Really? Assignment 1, 2, 2, 2, take me to assignment 2. It is RAG. Huh. Did we go through this? I don't feel like we did. Oh, sorry. I swear to God, I read who is suffering instead of who is offering. Hey. Okay, brain. But like, I like that. I like RAG now. I don't know why. I really, it's like the hot thing. So, I'm gonna look at it and just try and fail at it, you know? The usual thing.
Like scrape more research data or something like that. So there are methods to do this more systematically, and this is something I picked up when I was doing an internship at Google, and it really stuck with me for 14 years now, I guess, 13 years.
Wow.
So a very simple way to do this more systematically than just browsing through things is to randomly sample 100 outputs and look at 100 errors and try to group them into some sort of typology and say, oh, this kind of error is particularly frequent. And this is just one example of a typology that was defined by Villar et al., where they tried to take machine translation errors and group them into various varieties, like correct words, filler words, local range, long range, word level, word ordering errors, local range, long range, phrase level, local range, long range, and stuff like this. You can definitely look at previous work and see the typologies of errors that they used. But the problem is, like, systems get better. And actually, I don't think this is a super relevant typology for machine translation anymore, because machine translation systems, like, they don't make a whole lot of local range word level errors anymore. And rather, we might want to know more fine-grained, like, are they making mistakes on named entities or other things like that? So actually, we
We what?
did a more recent thing. It's, I guess, 4 years ago now, but it was when people first started saying that machine translation systems are about as good as humans at doing translation. And when we did this, we compared machine translation systems to humans, and we tried to find different types of things. And we were inspired by Villar, but we recreated our typology based on the things that we thought were the most important types of errors in like 2020 instead of 2006. So this is really helpful. The reason why it's really helpful is if you can do this, even for a small sample of the outputs that you're looking at, and identify the most like prominent types of errors that you're facing, it often leads you to the most successful ways of improving the accuracy of your systems. Because you might, if you don't do this, you might be focusing on an error type that's not actually an error. It's kind of like if you learned in programming, software engineering or something like that, you should never optimize your code until you run a profiler, because actually your code might be slow in a place that you never expected. And so it's kind of the same principle here, right? So don't optimize your system's errors in a place where like actually it's
Okay, don't make it more confident about problematic errors. That's cool.
not having any errors. So that's a general principle here. Cool. Another thing you can do is quantitative analysis. So if you can think of the phenomenon that you choose to focus on, is that phenomenon getting better? So if you focused on something that should improve the quality of low frequency words, you can.
I really shouldn't nitpick about this, but when he tries to go into full screen mode, he goes to the menu and then does it. And I don't know why. I'm like, why? Like you either just make it bigger or you, I don't know, like I saw there's a shortcut, Command F. I don't know why I'm being nitpicky about this. Um, anyway, you know, when you're young and you see people using computers and doing like shortcuts, using keyboard, without things happening, without them moving the mouse, that feels like magic. And I'm like, continue the magic. Don't show people what you do.
And check if the accuracy on low frequency words is increasing. If you focused on something that should be improving the syntax in a low resource language, you can measure whether it's doing better on word ordering or long distance dependencies. If you focused on improving a search algorithm for generation or something like that, are the number of search errors that you're encountering being reduced? So depending on what you planned on improving, it's often a good idea to measure more directly whether it's improving the thing that you think it should improve. One example of so I basically created, since my experience doing this manually when I was on an internship at Google, I've gradually improved my methodology for doing this.
No way.
And worked on automating things. And so the first thing I had was a super hacky script that basically writes out HTML files. And then I had something called Explainaboard where we had a leaderboard. And recently, one of the things I've worked on is this together with Alex Cabrera, who's a student here.
This is so cool.
Is this toolkit called Zeno. And this is just an example from machine translation.
What is Zeno? What does it
a little
do?
bit slow. But basically what it does is it allows you to look at the data.
He did do that on purpose. He did do that for me. Yeah.
On the right side. And so these are just examples. But you can go in and do things like say, okay, I want to look at all machine translation examples from Hausa. And so it shows you all the ones from Hausa. I want to look at all examples. Let me clear that off. I want to look at all examples where the accuracy is low.
What is Zeno? Oh, paradox. I didn't know that. Zeno's paradox. Oh. So, four paradoxes dealing with counterintuitive aspects of continuous space and time. Okay. Oh. If that infinite number of half steps needed is balanced by the increasingly short amount of time needed to traverse the distance. Interesting. The halving and halving motion is impossible. Too many. Okay, so you'll never get there, basically. Huh. It does feel counterintuitive. So fancy. I mean, from what I see, this is using. Why does it look like it's using R? Oh, I should be. It's probably Python.
Low. And so now I can look at all the examples where the accuracy is low, and I can go in and examine them. So you can also go in and build charts like this. So like, what is?
I swear this looks too much like R. Help me. Is there? Okay, so there's an R library. What did I forget? It's a GUI one. Yep. What is it called? What is it called? Oh well, I forgot. But there's a really beautiful one, and this looks too much like it.
So overall performance, what is the performance on different scripts? So you can see which model is doing better at scripts and stuff like that. So or you can put things side by side and say, okay, I want to find all the examples where ChatGPT is doing much worse than GPT-4. Or like GPT 3.5 is doing much worse than GPT-4. And here we can see that, oh, in this case, it's generating something in the wrong script.
Okay. Why are the examples always in Kurdish?
Or something like that. So there's also tooling that you can use to make this easier as well. And the way you use this is you basically
I mean, I wasn't being mean. I was like happy about it. Look, I found the site. Wow, this is really cool. Ooh, fancy. No way. We have audio even? Okay, that's too fancy for me. But like it's only eval. Okay, you have, okay, I see dark mode. I love it. Got it.
create a pandas data frame with all of your data in it, and you upload the pandas data frame with any metadata you want to use, and you can use that. And I think VJ will be having a recitation on this if you're interested in taking a look. Cool. So that is my part, and then we'll be doing Nishant next while Nishant comes up to set up. Are there any questions about the thing that I talked about here? Yeah.
So for Llama, the mini Llama assignment, I've noticed that when I applied regularization, my losses shifted sort of like in the size.
Mhm.
In terms of like their actual pattern, they all converge to 0. Does that make a difference in terms of like what we're expecting when we're evaluating the model block?
Yeah, so just to repeat the question, it's a great question. So if you apply regularization, will that change the overall expectation for the model loss? So I was saying loss should converge to 0. Once you start applying regularization or weight decay or something like that, it definitely might not converge to 0.
Okay.
And the reason why is because once you start applying regularization, there is no 0 loss solution. Because in order to reduce the loss, you need to move weights away from 0. But when you move weights away from 0, the regularization loss becomes non-negative. So one thing you can do, however, is measure the losses separately. So measure the regularization component of the loss and the log likelihood component of the loss. And with any reasonable regularization and a reasonably parameterized model, I do think the loss should be getting closer to 0. Like the actual likelihood loss should be getting close to 0 also. Yeah. You were using an extremely small model in the mini Llama assignment, though, so that might make it more difficult. Yeah. Any other?
They're talking about the first assignment. Oh my
Okay.
God.
If not, I'll...
Did you see that he has a microphone that it's not being used for the computer? Probably being used for the class. Oh well, we're done here. We're gonna clock in the time for next time. And we're gonna quickly look at the assignment. I don't expect to understand it, but we'll try. So, LLMs such as Llama 2, we have Llama 3 now. Is it? Have been shown effective for question answering. However, they are often limited by their knowledge in certain domains, obviously. A common technique here is to augment LLM's knowledge with documents that are relevant to the question. In this assignment, you will develop a retrieval augmented generation system, a RAG system. Oh wow, Lewis created it. Cool. That's capable of answering questions about the Language Technology Institute and Carnegie Mellon University. That's cool, huh? Um, so wow. So far in your machine learning classes, you may have experimented with standardized tasks and data sets that were easily accessible. Oh my God, this is torture. They're like, you're gonna have to um, collect data with your eyelashes. I don't know if that's a saying in any other languages, but you know it's impossible. Yeah, anyway. However, in the real world, NLP practitioners often have to solve problems from scratch, like this one. This is too much like the real world. This includes gathering and cleaning data, annotating your data, choosing a model, iterating on the model, and possibly going back to change your data. In this assignment, you will get to experience the full process. Wow, torture. Please note that you'll be building your own system end to end for this assignment. There is no starter code. You're kidding me. You must collect your own. I mean, the data part, okay, but the running part, there has to be something. Develop a model of your choice on the data. We will be releasing the inputs for the test set a few days before the assignment. You just they're thrown in the ocean and they're like, you know what? Swim. You will run your already constructed system over this data and submit the results. You'll also ask your fellow ask you to follow. Okay, sorry, eyes. Several experimental best practices and describe the result in your report. Yeah, checkpoints. Okay, data format, preparing raw data. Okay, there is some help at least, but yeah. Oh, nice, beautiful soup. I've heard that. Annotating test data, training data. Okay, so I wanted to see if there's any help regarding the RAG system. You can try LangChain's RAG stack, utilize GPT for all, Chroma, and Llama 2. Hmm. Wow. This is cool. I'm gonna get back to this. When am I going to get back to this? My question is, okay, so this is spring 2024. I want to check fall 2024 because I am guessing repos. There it is. It's probably, oh shoot. It's probably llama. Oh, okay. Um, oh wow, hey, I'm here. Wait, is that the assignment number 2? Why did we jump to assignment number 2? I'm just guessing that it's updated. No, it's not. Oh, it's still llama 2. Oh well. Cool. All right. Okay. 3 weeks ago. All right. Test set. Hmm. Test questions. All right. Cool. Okay. So eval is still running. Do not expect it to end anytime soon. Yeah. I don't know when this is due though. Like not due, but like when it starts. If you go back to where's the website? Right here. if we go back here, and go to, I'm guessing schedule. Okay, that should help. Assignment 1, assignment 2. We are in lecture debugging, and so we are here. So we're technically where assignment 2 should be, even though, yeah. So you finish this, and then assignment 2 you should work on, because it's due in 2. I feel like at least this lecture should be finished, but that probably will not change anything for me. God, okay. Okay. Before I lose my mind, I'm gonna try and end this stream. Don't forget to smash the like button and hit the subscribe button with a hammer. Yeah, okay. So I'm glad I did today's stream, because I was like 50% not feeling it, and the fact that the coffee wasn't preparing itself for me made it worse. But it's okay. We're here. We did it. We made it. Thank you for being here. Astaghfirullah. There we go. We're good. Starting next, which is tomorrow actually, next stream, we'll be going with the question answering. We're probably starting here. I don't expect this code to run by tomorrow, so don't expect answers. Yeah, and then maybe I can dedicate a stream to this. I just don't think I can do anything about it, you know? Huh? Oh wow, look. Billie Eilish is performing. Anyway. Wait, isn't this the CMU? Or is that different? This is not about CMU? It's not only about CMU. It's about Pittsburgh and CMU. There we go. Okay. Okay. Yeah. Thank you for helping me stay consistent with my learning, even though I'm not doing a great job. I'm trying, you know? That's okay. That's pretty good. I hope in some way I can somehow encourage you with your learning, because when you see me fail at learning and still continuing, should be encouraging enough for you. Um, yeah, thank you for being here, and I'm gonna end the stream in starting from a countdown of 5. If there's anything else, let me know. I'm available on way too many social platforms that are linked either below or around. So, yeah. Okay, ending the stream in 5, 4, 3, 2. I want to do the goodbye wave. There we go. 1. There we go. Okay. Thank you, and see you tomorrow.